Hello everyone. Today we are going to see two dynamic programming problems, and the second one is going to be part of your homework. So the first problem is as follows. We're given two parties A and B. Each of these parties, people are going to be voting for each of these parties. We are also given n persons. Each of these persons contain n people, and each of these people is going to be voting either for A or B. Now the problem is as follows. We're going to see whether given persons P1 to Pn and the number of votes in each of them. So we're assuming that Vi, for example, is the number of votes that the people in persons I are going to give to party A. Now we want to see whether we can divide these persons into two groups of equal size. So group 1 and 2, each of size n over 2, and so we want to see whether we can make this division such that A has the majority of votes in both of these divisions, both of these groups. And we're going to do the same for B. If either of these two is true, then we say that the set of persons is susceptible to gerrymandering. Now, to be a bit more clear, let's take a look at an example. Assume that we have 4 persons, and these are the numbers of votes that they have, and m here would be 100. So in each of our persons we have exactly 100 people. Now, if we put persons 1 and 4 together in one group and persons 2 and 3 together in the other group, so what will happen? In the first group, we are going to have 102 votes for party A, and in the second group, we are going to have 103 votes for party A. So party A has been able to achieve the majority in both of these groups. So now in this case, we say that this set of persons are susceptible to gerrymandering. And so this is a problem. We're given a set of persons and we want to see whether we can divide them somehow into two groups of equal size, so n over 2, such that then A would have the majority in both of them, or B could have the majority in both of them. Now, before we move on to making our dynamic program subproblem, let's see what condition do we need here. So assume that, as I said before, Vi is the number of votes for party A from person I. And assume V is the total number of votes. Now assume that the answer to the problem is true, and I've been able to divide these persons into two groups such that it is susceptible to gerrymandering. So such that A has achieved the majority of votes in both of them. Now, if V1 is the number of votes A has in the first group and V2 is the number of votes it has in the second group, then we will have this relation here. Now, okay, so we are assuming we have two groups, 1 and 2. Each of these groups has n over 2 persons, and so mn over 2 people voting. Now, I want V1 to be the majority of votes, so I need to have this relation, right? So mn over 2 is the number of people in the group, and mn over 4 is half of them. The plus 1 would give me the majority. The same thing should go for V2, right? And I know that this V2 here is V minus V1 because of the way that we defined it. So now we can put these two relations together and come up with this relation. So this is the necessary and sufficient condition that we need for this partition to work for us. Okay, now let's move on to what variable, what subproblem we're going to define for our dynamic program. So now, instead of considering all the persons together, at this point we're going to consider and limit ourselves into only the first I persons. So I'm just considering the first I persons. Then I'll say that I will be picking k of these I persons, and I want them to give me the number of votes v. So d of I k v, this is a Boolean variable now. So this might be a bit different than whatever dynamic programming we have seen before, because our subproblem now is not a number, but it is a Boolean. So d of I, k, and v means that considering the first I persons, am I able to pick k of them such that they would give me the total number of votes v to party A or not? So it's true if I can, and it's false if I cannot. Now let's see how I can fill this up recursively. So consider the last persons we have here. So consider persons I. I am either going to pick person I or not. Let's say I did pick it up. Then what do I need to look at? So I have picked one person, so now I should be limiting myself to the first I minus 1 ones. And well, my k would be decreased by 1 because I have picked one person. And the number of votes that I need now would be v minus vi. So if I decide to pick person pi and include it in my group, this is the next thing I need to consider. Now the other case is I don't pick person pi, in which case again I need to consider the first I minus 1 persons, but this time I still need to pick k ones, and I haven't gained any votes for A, so I would still have a v here. Now have in mind each of these two variables are Booleans. So now the thing that I need to consider here is exactly OR of these two subproblems or variables, and here's why. So I'm saying that okay, when I'm considering the first I persons, I have two cases. Either I pick pi or I don't pick pi. And if I decide to go either way, I need to have at least one of these two to be true so that my d of I, k, and v is true. Because if, for example, I'm not able to pick k of the first I minus 1 person such that they would give me v votes, then the case where I don't pick up pi would not yield a true value for d of I, k, and v. And the same logic goes for the other case. And so this is how we will define our recursive relation. Now let's take a look at how we can fill this table up. So here are the base cases that we need to be considering. First of all, if I have only one person I'm considering, and I just want to pick one, and I want v votes, what would be this value? So basically this is telling me I have only one option. I have the first person, and I can, well, I need to pick one, and I need v votes. So this would be true if v is equal to vi, and otherwise it would be false. Because exactly this is the only option that I have. I have to pick person number 1. The other set of base cases we have is this. So here assume that k is greater than I. So the number of people the number of persons I want to pick from the first I persons is now more than I. Well, what would that mean? It means that I can't do that, right? If I have only I options and I want to pick some k of them, which k is greater than I, well, this is not doable. So if k is greater than I, then this is not doable. So this would be the second set of our base cases here. Now let's see what we would need to return in the end using these sub-problems here. We're going to see what we should do with this sub-problem. Which of them is going to give us the answer. Now, if we take a look back again at the condition we found for number of voters we need in, say, the first group, this is the relation we came up with. So if V1 is the number of voters we have for A in the first group, we need to have Mn over 4 plus 1 is less than or equal to V1 and is less than or equal to this. So if the value of my V1 is anything within this interval, then we are good. So what we need to look into is what? D of, okay, first of all, we are considering all the persings, so I need to consider all the n persings. Then we know that I want to pick half of them, so we need to have an n over 2 here. And this v of us should be exactly this v1, should be exactly in this interval here. So what we need to do is to look into all values of d of n, n over 2, and v1 iterating between mn over 4 plus 1 and v minus mn over 4 minus 1. Once we did this, if any of these d's are true, then we return true as the result of our problem, otherwise we'll return false. But have in mind we need to iterate the exact same process for b as well, and mainly take the OR of the answers we get from each of these procedures. So this is how we come about this problem. Now let's move into the next problem. Before we do that, let's also take a look at the running time of our algorithm. So the table we're filling up is, so the number of our subproblems is, so value of I is within 1 to n, our number of persings, and our k is also the same way. It's actually less than or equal to I, because we said that if k is greater than I, then it's false. So we really don't need to consider those, but you could, for simplicity, you could consider this this also as n when you're just considering the running time of our problem. And this v here, so v is at maximum the total number of votes for party A, and well, that number is at most m times n, right? We have n times n people, so the total number of votes for party A can be at most that. And also in our updates at each iteration in our recursive call, we're doing only a constant amount of actions, because we are just considering the OR of 2 other variables. So it's constant time. So our runtime would be the multiplication of these, and would be O of m and q. So this would be the runtime of our problem, and well, we solved it using dynamic programming.